In this video, we're going to do a review of linear equations. It's especially for those of you who have a test that you're studying for. So let's begin by writing down some notes. There are three forms in which you can write a linear equation. The first one is known as the slope-intercept form. In the slope-intercept form, the linear equation is written this way. Y is equal to mx plus b. M represents the slope, which we'll talk about later, and b, that represents the y-intercept. We'll also talk more about that later as well. But for now, you want to write this equation. So this is the slope-intercept form of a linear equation. Now the next form that you want to be familiar with is the standard form. So to write a linear equation in standard form, this is how it's going to look like. It's ax plus by is equal to c. A, b, and c are simply coefficients. X and y are the variables. But when written in that form, it's called the standard form. The next form that you need to be familiar with is this one, the point-slope form of a linear equation. It's y minus y1 is equal to m times x minus x1. As the name implies, this equation can tell you the slope and the point. The slope is the value of m. So whatever number you see here, that's the slope. The point is x1 comma y1. Now let's talk about the slope. The slope is equal to the rise divided by the run. So let's say if you have a linear equation that is rising, the slope is going to be positive. And let's say you have 2 points on this line. Now to go from the first point to the second point, let's say you have to travel up by 4 units. This is not drawn to scale, by the way. This is just an illustration. So let's say you travel up 4 units, and then you travel 3 units to the right. So in this case, your rise is 4, your run is 3. So rise over run, the slope would be 4 over 3. And because it's going up, the line is going up, the slope is going to be positive. Now here's another example. Let's say to go from this point to that point, we need to go down 3 units. So the rise is negative because we're going down. So let's say negative 3 units. Let's say we have a run of positive 5. It's positive because we're moving to the right. The run should always be positive. Now for this one, the slope is going to be rise over run. The rise is negative 3. The run is 5, so it's going to be negative 3 over 5. So because the line is going down, the slope is negative. So that's a quick and simple way to calculate the slope using the rise over run method. Now whenever a line goes up at a 45-degree angle, the slope of that line is going to be 1. If it goes up like this, it's about 1/2. And if it goes up even steeper, let's say like this would be a slope of 2. So this line is very steep compared to the other ones. Now if the line is horizontal, the slope is going to be 0. If it goes down at a 45-degree angle like this, the slope is negative 1. Here it's about negative 1/2. And here, negative 2. So anytime the slope increases, anytime the line increases, the slope is going to be positive. if the graph is going down, the slope is negative. And for any horizontal line, the slope is 0. So if you have a line that's going to the right or to the left, the slope is 0. For a vertical line, the slope is undefined. As the line becomes more vertical, the slope increases. Eventually, it can go up to infinity, and at some point, it will be undefined. So just know that. So if you have a vertical line, the slope is undefined. For a horizontal line, the slope is 0. Now you can calculate the slope of a line if you know the 2 points. So let's say if the first point is x1 comma y1 and the second point is x2 y2, the slope of the line is going to be y2 minus y1 divided by x2 minus x1. So here's an example. Let's say the first point is 2 comma 5 and the second point is, let's say, 5 14. Go ahead and calculate the slope. So y2 is going to be 14, and let's replace y1 with 5. x2 is 5, x1 is 2. 14 minus 5 is 9, 5 minus 2 is 3, 9 divided by 3 is 3. So the slope of the line that connects these 2 points is equal to 3. Now let's talk about x and y intercepts. What is an x-intercept and what is a y-intercept? What do you think the answer to that question is? An x-intercept is a point, but it's a specific point. The x-intercept is the point where y is equal to 0. So let's say you have the point 3 comma 0. At this point, x is 3, y is 0. This particular point is an x-intercept because the y value is 0. So the x-intercept is any value of x when y is 0. Another example of an x-intercept is the point -5, 0. So the x-intercept in this case will be -5. If we have the point 2 comma 0, the x-intercept is 2. So any point where the y value is 0, the x value is the x-intercept. For the y-intercept, the situation is reversed. The y-intercept is the y-coordinate of a point when x is 0. So let's say if we have the point 0, 4, the y-intercept is 4. So remember, when dealing with linear equations, the y-intercept is also equal to b. So we would say that b is 4. Here's another example of a y-intercept. Let's say the point 0, -3. So x is 0, y is -3. The y-intercept is -3. So we can say that b is equal to -3. Now let's summarize what we've just learned. The x-intercept is the x-coordinate of a point that contains a y value of 0. So as we see here, this point has a y value of 0. The x-intercept is the x-coordinate of that point. So x is -5. The y-intercept is the y-coordinate of a point that has an x value of 0. So for this point, the x value is 0, but the y-intercept is the y-coordinate of that point. So it's y equals 4 or b equals 4. So that's the basics of the x and y intercepts. So here's an example problem for you. Consider these 4 points, the point 2 comma 5, -3 comma 0, 1 comma 2, and 0 comma 6. Given these 4 points, identify the x and y intercepts. So this point here has a y value of 0. Therefore, that point represents the x-intercept. The x-intercept is specifically the x-coordinate of that point. So the x-intercept, we could say it's x equals -3. But you can also say that the x-intercept is the point -3, 0. You can describe it both ways. The y-intercept is the point where x is 0. So this would be the y-intercept. Now you can say the y-intercept is y equals 6, or you can say it's b equals 6. Now the next thing that we need to review are parallel lines and perpendicular lines. So what's the difference between parallel lines and perpendicular lines? What would you say? And how do their slopes relate to each other? Parallel lines, they travel in the same direction. Let's call this line 1 and line 2. Let's say the slope of line 1 has a value of 2. If the slope of line 1 has a value of 2, and if line 2 is parallel to line 1, the slope of line 2 will be the same. It will also be 2. What you need to know is that parallel lines, they have the same slope. So m1 is going to be equal to m2. You can also describe the relationship between two lines that are parallel using this symbol. If you see this double vertical line, it means that the two lines are parallel. So this is saying L1 is parallel to L2. But for linear equations, if you have a test, what you need to know is that parallel lines, they have the same slope. Now let's talk about perpendicular lines. Let's say we have this line, which we'll call L1, and then this line, L2. Perpendicular lines, they intersect at right angles, that is, at 90 degrees. The slope of the perpendicular line is the negative reciprocal of the original line. So let's say the slope of line 1, let's say it's positive 3/4. The slope of line 2 is going to be the negative reciprocal. So you got to change the sign from positive to negative, and you got to flip the fraction. So it's going to be -4/3. So m1 is going to be -1/m2. So that's the relationship between the slopes of two perpendicular lines. So we could say L1 is perpendicular. This is the symbol for perpendicular. L1 is perpendicular to L2. You can see these two lines meet at right angles. So that's how you can describe two perpendicular lines. So remember, the slopes are negative reciprocals of each other. Now let's work on some example problems. Let's say that line 1 is parallel to line 2. And let's say that you're given the slope of line 1. Let's say that the slope of line 1 is -3. What is the slope of line 2? If they're parallel, the slope of line 1 is equal to the slope of line 2. Therefore, the slope of line 2 will be -3. Now let's say that line 1 is perpendicular to line 2. And let's say you're given the slope of line 1. Let's say it's -4/7. What is the slope of line 2? The slope of line 2 is going to be the negative reciprocal of the slope of line 1. So the first thing you need to do is change the sign from negative to positive. And then you need to flip the fraction from 4/7 to 7/4. So that's going to be the slope of the line that's perpendicular to the first line. Now let's talk about how we can graph equations in slope-intercept form. So let's say we have the equation y is equal to 2x minus 4. How can we graph this equation? So first, let's put in some marks on the graph. Feel free to try this example if you want to. So the first thing we need to identify is the slope and the y-intercept. So this is in y equals mx plus b form. It's in slope-intercept form. So we can see that the slope is equal to 2. And we can see that the y-intercept is -4. With this information, we have everything that we need in order to graph this function. So here's -4. Let's go ahead and plot the y-intercept. And then from the y-intercept, we can get the second point by using the slope. So the slope is 2, which means that it's 2 over 1. So the rise is 2, the run is 1. So to get the next point, we're going to go up 2 units and then travel 1 unit to the right. So that will give us the point 1, -2. So we have an x value of 1 and a y value of -2. Now let's go up 2 and over 1 again. So we get the next point, which is 2, 0. So that's an x-intercept. The x-intercept is the point of the graph that touches the x-axis, because on the x-axis, y is 0. The y-intercept touches the y-axis. So this point is 0, -4. It's the y-intercept because x is 0, and this is the x-intercept because y is 0. Now all you need is 2 points in order to graph a line. So we can add more points, but we can just connect these points with a straight line. So that's how we can graph this equation in slope-intercept form. Now let's say we have this one, y is equal to -3 over 4, x plus 5. How can we graph this equation? Feel free to pause the video if you want to try it. So first, let's identify the slope and the y-intercept. So we can see that the slope is -3 over 4. It's the number in front of x. The y-intercept is 5. So first we're going to plot the y-intercept. The y-intercept has the point 0, -5. X is 0, y is -5. So it's on the y-axis. This is the x-axis, this is the y-axis. So now that we have the first point, the y-intercept, let's use the slope to get the next point. So starting from the y-intercept, we have a rise of -3 and a run of 4. So this is the rise, this is the run. So as we travel down 3 and over 4, it's going to take us to this point. So that is 4 on the x-axis, 2 on the y-axis. Now all we need is 2 points to graph a line. So now we can just draw a line that connects those 2 points. And so that's how we can graph that particular linear function. Now let's move on to the next example. So this time we're going to graph a linear function in standard form. So we have 3x minus 2y is equal to 6. So it's an ax plus by equals c format. How can we graph a linear equation in standard form? What do you think we need to do? One of the most simplest techniques that you can use is to find the x and the y-intercepts. To find the x-intercept, replace y with 0. Negative 2 times 0 is 0, so we get just 3x is equal to 6. Solving for x, we can divide both sides by 3. And so we get x is equal to 6 divided by 3, which is 2. So the x-intercept is 2 comma 0. X is 2, y is 0, since we replaced y with 0. Now let's find the y-intercept. To find the y-intercept, replace x with 0. 3 times 0 is 0, so we're just going to get negative 2y is equal to 6. Dividing both sides by negative 2, we get that y is 6 divided by negative 2, which is negative 3. So the y-intercept is going to be 0, negative 3. So what we're going to do is we're going to plot the x-intercept, which is here. It's 2 comma 0. And then let's plot the y-intercept. The y-intercept is 0, negative 3. So now let's connect these 2 points with a straight line. And that's all you need to do in order to graph a linear equation in standard form. Let's try another example. So let's say we have 4x plus 3y is equal to 12. Go ahead and graph that linear equation. So let's find the x-intercept. Let's replace y with 0. So we're going to get 4x is equal to 12, and then dividing both sides by 4. We get x is 12 over 4, which is 3. So the x-intercept is 3 comma 0. Now let's get the y-intercept. So this time let's replace x with 0. 4 times 0 is 0, so we just get 3y is equal to 12. Divide both sides by 3. So y is 12 divided by 3, which is 4. So we get the point 0 comma 4. So the x-intercept is at 3, the y-intercept is at 4. And then we just need to connect those 2 points with a straight line. So that's how we can graph the linear equation in standard form. 4x plus 3y is equal to 12. Now what about an equation that is in point-slope form? Let's say we have y minus 3 is equal to 2 times x minus 2. How can we graph an equation in that form? Feel free to try that problem. So this is in y minus y1 is equal to m times x minus x1 form. That's the point slope form. In that form, we could find the point and the slope. So here's the slope. The slope is 2. Now we can also find a point through which the line passes through. And that point is x1, y1. So what's x1 and what's y1? Notice that these two negative signs are the same. Therefore, x1 has to be positive 2, because those negative signs are already there. So x1 is positive 2, y1 is 3 without the negative sign. So when you see x minus 2, the point is going to be 2. Change the negative sign into a positive sign. If you see y minus 3, the y coordinate is positive 3. So with this information, we can graph it. We have a point and a slope. So let's plot the point 2, 3. So here is 2, 3. The x value is 2, the y value is 3. And then we could use the slope to get the next point. The slope is 2, so we have a rise of 2 and a run of 1. So we can go up 2 and over 1 to get the next point. So that's going to be 3, 5. And we can go backwards. Let's say if we go 1 to the left, we need to go down 2, because there's not much space in the right side of this graph. So that's how we can graph a linear equation in point-slope form. For the sake of practice, let's do one more example. So let's say we have the linear equation y plus 4 is equal to negative 3 over 2 times x plus 1. So go ahead and graph that linear equation. So let's begin by identifying the slope. The slope is negative 3 over 2. Now what's the point? Here we have x plus 1. The x coordinate is going to be negative 1. Simply reverse positive 1 to negative 1. Here we have y plus 4. The y coordinate will be negative 4. So now we have a point and a slope. That's all we need in order to graph this function. So the first point is at negative 1, negative 4, which is here. The x value is negative 1, the y value is negative 4. And then to get the next point, the slope is negative 3 over 2. So we need to go down 3 and over 2. But it looks like we're out of space. So we're going to go backwards. That is, we're going to go up 3 and then 2 to the left. So up 3, 2 to the left, that still gives us the same slope. That's a rise of 3, a run of negative 2, which is still negative 3 over 2. So sometimes you may need to go backwards, like in this problem. So if we go up 3 and over 2, we should be at this point. And this point is at negative 3, comma, negative 1. Now at this point, we can go ahead and draw a line between these 2 points. So that's a rough sketch of the graph that corresponds to this linear equation. Now, what would you do to graph this equation? Let's say y is equal to 3. How can you graph that? Whenever y is equal to a constant number, what you're going to get is a horizontal line. In this case, a horizontal line at 3. So if we wanted to graph y is equal to negative 2, we would simply draw a horizontal line at negative 2 along the y-axis. So whenever y is equal to a constant, you're going to get a horizontal line. And the slope of that line is going to be 0. Now, what if we wanted to graph x is equal to 4? In this case, we're going to have a vertical line at x equals 4. So this line will contain all points with the x coordinate x equals 4. The slope of that line is undefined. If we want to graph x is equal to negative 3, it's simply going to be a vertical line touching all points with the x coordinate negative 3. So that's how we can graph that. Now let's work on some multiple choice and free response practice problems. That's going to help you to review for the tests if you're studying for one. Number 1. Which of the following graphs correspond to the equation y is equal to 2x minus 3? So this equation is in slope-intercept form. Now there's 2 things we need to focus on. We need to identify the slope and the y-intercept. The slope is the number in front of x. So therefore the slope is equal to 2. The y-intercept is the constant that you see next to the 2x. So the y-intercept, which is b, is negative 3. So let's identify the graph with the correct y-intercept. If we look at answer choice A, the graph touches the y-axis at positive 3. Therefore, answer choice A is not correct. Looking at B, C, and D, the graph touches it at negative 3. So far, C, B, and D are okay. Now let's look at the slope. The first thing we want to notice is that the slope is positive. A positive slope means that the function is increasing. A negative slope means that it's decreasing. And for a horizontal line, the slope is 0. So because the slope is positive, the graph should be going up. Therefore, we can delete D because it's going down. Graph D has a negative slope. Now, between B and C, what's the difference? Well, let's look at C. As we travel 1 unit to the right, notice that the graph goes up by 3. So the slope is 3. Now let's look at B. As we travel 1 unit to the right, notice that the graph goes up by 2, which gives us a slope of 2. So B is the right answer. It has a y-intercept of negative 3 and a slope of 2.